Okay guys, welcome once again. I am Mr. Shahbaz Alam, assistant professor from ABS Engineering College. In the previous lecture, we have discussed the application of PN junction diode as a voltage multiplier circuit. Now, in this lecture, I am going to discuss some special purpose two terminal devices, that is special purpose diode. These diodes are manufactured or these diodes are used for the achievement, for the fulfill of various special purposes. And these special purpose diodes are Zener diode, light emitting diode, varactor diode and tunnel diode. Zener diode. Zener diode is a highly doped diode. Due to highly doped, this diode works in forward bias as well as in reverse bias. And especially in reverse bias, once the Zener diode gets breakdown, the voltage across the diode remains constant, and this feature or this behavior of this diode is used as a voltage regulator. Why voltage regulator? Because for voltage regulation, the voltage should be constant. Since the voltage across the Zener diode, when it gets breakdown, the remains constant. This means we can use this diode as a voltage regulator by connecting this diode across any two terminals. This means across any load resistance or load terminal. On the other hand, light emitting diode. Light emitting diode emits the various colors of light, and this diode is manufactured for the optical confinement, and this diode can radiate or this diode can emit various colors like red, infrared, green, yellow and etc. Especially the application of LED are in various areas like in remote system, in LED bulb and in optical fiber communication, LED screens and 7-segment display and in the traffic lights, and everywhere we are using the LED, and we will discuss it in later. Now, varactor diode. Varactor diode is a diode which is used as a variable capacitor, and also the varactor diode is also known as the varicap. This means we can use this diode to change the capacitance, especially in the tuning circuit. When we will change the capacitance of the varactor diode, the tuning frequency will be changed, because the formula of tuning frequency is 1 upon 2 pi under root LC. Now, the fourth one is the tunnel diode. टनल डायोड इज द मोस्ट डोप्ड डायोड, इसकी डोपिंग सबसे ज्यादा होती है. टनल डायोड कैन नॉट होल्ड द रिवर्स वोल्टेज. वंस वी अप्लाई द रिवर्स वोल्टेज, इट गेट सडनली ब्रेक डाउन. दिस मीन्स द टनल डायोड कैन नॉट होल्ड द रिवर्स वोल्टेज. दिस मीन्स वी कैन नॉट यूज द टनल डायोड इन एज अ rectifier circuit, in any rectifier circuit. On the other hand, in forward bias, just we apply the small voltage, it starts conduct due to the tunneling effect. We will discuss in the next lecture also. Now, in this lecture especially we will discuss the breakdown mechanism and about the Zener diode only, and in the next lectures we will discuss the LED, varactor diode and tunnel diode. Now, before discussing the Zener diode, we will discuss the breakdown mechanism of any diode. There are two types of breakdown. First one is the avalanche breakdown and second one is the Zener breakdown. Avalanche breakdown exists in those diodes, generally in the moderately doped diode, and Zener breakdown exists in the heavily doped diode. Avalanche breakdown exists at greater than 6 volt. On the other hand, Zener breakdown exists at low voltage, that is less than 5 volt. Now, avalanche breakdown. Avalanche breakdown exists at high voltage, and it is the different types of breakdown exactly. When we apply the reverse voltage, what will happen? Obviously, the conduction of minority carrier will start. As we increase the reverse voltage, the kinetic energy of the minority carrier will increase, half m v e square. Then this high kinetic energy electron will collide with the electrons at the covalent bond, and which will freeze the covalent bond electron into the conduction band. On the other hand, we can say that the highly kinetic energy minority carrier will push the covalent bond electron into the conduction band. And now further these two electrons will collide with the two further covalent bonds and they will freeze the two further electrons of covalent bond, and this is called the multiplication of charge carrier. This is called multiplication of the charge carrier, and due to the multiplication of charge carrier, the large number of electrons are available at the conduction band, which will conduct in the reverse bias, in the reverse direction, and we get a current and which is called reverse current, and this type of conduction is called avalanche breakdown. It's called avalanche breakdown. Basically avalanche breakdown, the basic cause of avalanche breakdown is the multiplication of charge carrier, and avalanche word comes from the snowfalls, when a small piece of ice slides from the top of a mountain, it becomes a large piece at the surface of the earth. This means this is the multiplication of snow. In the same way, in the reverse bias diode, the multiplication of charge carrier. In avalanche breakdown, the current increases gradually. This means the curve is not sharp. Why current increases gradually? Because as multiplication of charge carrier increases, the current will also increases. Now, I am going to discuss the Zener breakdown. What is the Zener breakdown? Basically, Zener breakdown exists in those diodes which are highly doped. Especially in the highly doped diode, the width of the depletion layer is very narrow. When we apply the reverse voltage VR, then what will happen? Here electric field appear across the depletion layer is intense, is strong. Why it is strong? Because the formula of E is the VR upon width. Suppose the width is the D, width of the depletion layer is D. This means since D is small, so that E is strong, and the strong electric field is called intense electric field. This means the number of lines of electric field passing through a unit area of cross section is high. This type of electric field is called intense electric field. Intense means ghana. Okay guys, then due to this intense electric field, strong electric field, what will happen? The strong electric field will pull out the large number of electrons from the covalent bond into the conduction band. This means the strong electric field will freeze the large number of covalent bond into the conduction band, and this conduction band electron will suddenly starts conduct in the reverse bias, and a large current is also starts flow in the reverse direction, and this type of breakdown or this type of conduction is called Zener breakdown. This means in Zener breakdown, current increases suddenly. This means the curve is sharp, and Zener breakdown exists earlier and the avalanche breakdown exists in later. This means at a high voltage, and Zener breakdown exists at a low voltage. Especially in case of Zener diode, the breakdown mechanism exists in generally is the Zener breakdown. This is the root cause that after getting breakdown, the voltage across the Zener diode remains constant, and it is used as a voltage regulator. Now, I am going to discuss the Zener diode. This is the symbol of Zener diode, you guys can see, and this is the prototype piece Zener diode which is available in your college laboratory. Okay guys, in Zener diode, and the symbol is like that. At the N side this is written as plus, and at the P side this is written as minus. Why it is like that? Why it is different symbol from the p-n junction diode? Because p-n junction diode are used in the forward bias only. On the other hand, Zener diode are generally used in the reverse bias. It does not mean that it cannot conduct in forward bias. It can conduct in forward bias as a p-n junction, normal p-n junction diode, but it is differently conduction in the reverse bias. And so that in the reverse bias, we apply the positive voltage at the N side and negative voltage at the P side, and current flows from the N to P. So that we write here plus and we write here minus. Now, equivalent circuit of Zener diode. Why it is need to know, it is need to study the equivalent circuit of Zener diode? Because ideally when the Zener diode is in reverse bias and it gets breakdown, the voltage across the Zener diode remains equal to the Zener breakdown voltage, that is Vz. Here this is the Vz. It is ideally if it is in the forward bias, because the resistance, dynamic resistance of the Zener diode is ideally 0. On the other hand, it may practically up to few ohms, and if the Zener diode is not gets breakdown, this means the sufficient reverse voltage is not applied there, then it become open circuited, because if Vz is greater than the reverse voltage appear across the Zener diode, then what will happen? The Zener diode will not get breakdown. Then what will happen? The reverse current will not follow. This means this is the open circuited. But what is the question? That if the Zener diode is practical, then what is the equivalent circuit? Suppose Zener diode is practical and it gets breakdown, then the equivalent circuit of the Zener diode is like this. This is Vz and this is the small Rz, and current flowing through the Zener diode is Iz. And why this is Rz? Because as we know that Rz is the dynamic resistance or AC resistance. Okay guys, and Rz is defined as this triangle law. This is the delta Vz and this is the delta Iz. And Rz is defined as the delta Vz upon delta Iz, and this value is up to some ohm, few ohms only, few ohms, up to few ohms. This means the value of Rz is up to like that 2 ohm, 3 ohm, 4 ohm. The value of Rz is very small, so that we can say that voltage across the Zener diode remains constant. Now, Zener diode specifications. Specifications means what is the minimum Zener current, what is the maximum Zener current, what is the minimum power dissipation, what is the maximum power dissipation. All of us know that once the Zener diode gets breakdown, the voltage across the Zener diode remains constant ideally. Now, Iz minimum, this is the Iz minimum. Guys, this is the Iz minimum. What is the significance of Iz minimum? Minimum Zener current. The significance of minimum Zener current is that it is the minimum Zener current required to break down the Zener diode. This means if the Zener current is less than the minimum Zener current, it will never gets breakdown. On the other hand, there is a maximum limit of Zener current, that is called Iz maximum. The significance of Iz maximum is that beyond this value, a Zener diode cannot tolerate this Zener current, because it may gets burned or it may gets permanently damaged. This means Iz max is a maximum Zener current below which a Zener diode can work safely and properly. This means there is a Zener current that must be lie between the Iz minimum and Iz maximum. This means for Zener action means for voltage remains constant, the Zener current Iz must be greater than Iz minimum and less than equal to Iz maximum. If the Zener current is beyond these two range, the Zener diode will not work as a voltage regulator. This means the voltage across the Zener diode will not remains constant. Now, there are two values of power dissipation, Pz minimum and Pz maximum. For minimum Zener current, there is a minimum power dissipation, minimum heat dissipation, and now for Iz maximum, this is the maximum power dissipation, Iz max. This means Pz max, Pz max is equal to Iz max into Vz, and Pz minimum is equal to Iz minimum and Vz remains constant. Now, application of Zener diode as a voltage regulator circuit. Now, if all three components are constant, this is the supply voltage, this is the series resistance, and this is the load resistance, and we are taking output voltage across the RL, and V output should be equal to Vz, and V output equal to Vz only when the Zener diode will get breakdown, or we can say the Zener diode will conduct in reverse bias only, and in this condition we will get the V output equal to Vz. This means there are only three equations in the voltage regulator circuit. I am going to write all three equations like this. First equation is V output is equal to Vz. This implies IL is equal to Vz upon RL. This is the first equation. Now, another one equation we can see that in the above circuit, that if we will apply here KCL, what will happen? In this circuit the current is suppose IR, and in this circuit the current is IL, and here it is IZ. This means IR should be equal to IZ plus IL. So, this is called Kirchhoff's current law. This means the series current IR should be equal to IZ plus IL. This is the second equation. Now, third equation, we will apply the node voltage method. For node voltage method, if we are taking this is called ground, or you can say the reference voltage, then the voltage at this point is Vz. If we will apply the Ohm's law, that is V input minus Vz upon R is equal to IR. Now, the third equation, IR is equal to the V input minus Vz upon R. So, this is only the three equations in case of Zener diode. Okay, guys. Now, we will discuss the Zener diode as a voltage regulator circuit in two different ways, when input is variable and load resistance is constant, and when load resistance is variable and input voltage is constant. Now, in this circuit V input is fixed, that is constant, and RL is variable. This is variable, okay, guys, and this is constant. Then what will happen? Only there are three equations we can write easily. Okay, guys. Then I am going to discuss all three equations in the same way. Suppose equation number 1, IL is equal to Vz upon RL. Okay, guys. Now, here Vz is constant, RL is also constant. This means IL is also constant. Okay, guys, the first analysis of this equation. In this case, RL is variable. No, RL is variable. Here RL is variable. Okay, guys. This means RL is variable here. Then what will happen? Vz is constant. This means here Vz upon RL variable. This means there are two values of the IL. Here IL minimum is equal to Vz upon RL maximum. On the other hand, IL maximum is equal to Vz upon RL minimum. So, there are two values of the IL. This means there are two values of RL also. This is the RL minimum and this is the RL maximum. Now, next equation, IS. We know that IS is equal to IS, or you can say here IR. IR is equal to IZ plus IL. Okay, guys. Here IL is variable. Here IL is variable. then what will happen? What is the equation of IR or IS? And this is the 2 and equation 2 and third. This is equal to V input minus Vz upon R. Here V input is constant and here Vz is also constant and here R is also constant. This means what will happen? This means the value of IR is also constant, but the value of IR is constant, but IR is equal to Iz plus IL. Here IL is variable in the first equation. This means Iz must be variable, then only the sum of these two current is constant. This means if IL increases, then Iz decreases. What is the meaning? If IL increases, then Iz decreases and vice versa. So, this is all about the condition of Zener diode as a voltage regulator for V input is constant and RL is variable. Now, in the next circuit, here V input is variable and RL is constant. Then what will happen here? Here also there will be three equations. The first equation here IL is equal to Vz upon RL. These two are constant here. This is also constant. This means IL is equal to constant. Now, I am merging the equation 2 and 3. What will be here? Here IR is equal to Iz plus IL and it is equal to the V input minus Vz upon R. And here V input is variable and Vz is constant, R is also constant. Then what will be here? If V input is variable, this means IR will also variable. Okay, guys? Since IL is constant, this value is constant and IR is variable. What does mean here? This means Iz must be variable. This means there are two values of Iz. One value is the maximum Zener current and another one value is the minimum Zener current. Then what will be the value of maximum input current and minimum input current? From this equation we can write the two values of input current. V input max is equal to Iz max plus IL into R plus Vz, and in the same way V input minimum is equal to the Iz minimum plus IL into R plus Vz. In some numericals, some cases only Iz maximum is given and Iz minimum is not given, then what will we do? Obviously, we will take the minimum Zener current is equal to 0, otherwise it should be given in the numerical. Okay, guys? So, this is the two values of the input current for regulation circuit. In some time it is asking in the question that calculate the range of input voltage so that the output will remains constant equal to 10 volt or 8 volt and whatever be the numerical value in the question. Then we can easily find the values of the numericals. Now, some questions are here. This is the question. Here it is asking that for the following Zener diode network determine the VL, VR, IZ and PZ. Here this is the 16 volt and it is 1 kilo ohm, it is 1.2 kilo ohm and Vz is equal to 10 volt, Pz max is equal to 30 milliwatt. So, in such circuit, first of all we should know that will the Zener diode will be in reverse bias and if will be the diode will be breakdown. क्या ये Zener डायोड ब्रेकडाउन होगा? तो सबसे पहले आपको ये कैलकुलेट करना चाहिए, अदरवाइज आपका कैलकुलेशन आगे चल के आपका गलत भी आ सकता है, क्योंकि हो सकता है Zener डायोड ब्रेकडाउन ही ना हो. तो व्हाई वी विल टेक लाइक दिस VL is equal to V output, because here it is not written that VL is equal to Vz. So that the necessary and sufficient condition is that to get the Zener diode breakdown is that Vz should be less than equal to V input upon R plus RL into RL. If this equation will exist, then only the Zener diode will gets breakdown. So, here V is equal to 8.73 volt. This means this value will be the 8.73 volt, 8.73 volt, and the Zener breakdown voltage is 10 volt. This means the Zener diode will never gets breakdown. The never gets breakdown means this will become open circuited. This will become open circuited. This means Iz will be 0. Now, we will open circuited, then this circuit is the only series circuit, and what will be the value of IR and IL, both are equal, and IL is equal to IR is equal to nothing, 16 upon 1 plus 1.2 kilo ohm. What will be the value? This is the equal. And what will be the output voltage? And output voltage is nothing, this is the 8.73 volt only. This means this circuit is the not regulator circuit. Why this is not regulator circuit? Because Zener diode does not gets breakdown. In the same way, there are various types of numerical guys we will solve. If you will face any issue, then you guys can write me an email or WhatsApp, then I will try to solve your questions. Thank you guys. See you in the next lecture.